Hi, this is Rohan from Team cHaOs. We participated in the ASHRAE competition on Kaggle and we finished in second place. Our team comprised of four members: Oleg from Germany, Anton from Germany, Yang Wen from China, and myself, Rohan from India. So I speak on the behalf of our entire team, sharing our entire solution. So going over the solution architecture, primarily we broke down the data at the site level. Since every site represented a geographical location, the idea was to explore all the buildings inside every site and to optimize the pre-processing, the modeling, the post-processing, as well as the ensembling for each site. Unfortunately, the sites 0, 1, 2, 4, and 15, the meter readings for the test dataset were publicly available. Thanks to some of the Kagglers who were kind enough to scrape this data and share it publicly on the forums, it helped make the competition fair and give everyone equal access to the leaked data. But for the sites 3 and 5 to 14, we followed a standard flow. So our solution involved four major components. So the first is the pre-processing. So this involved two key aspects, one being the removal of outliers, and this is one of the highlights of our solution. The dataset had a lot of meter readings where the value was 0. We were not sure whether these were valid data points or whether these are faulty readings, and some of them seem to be because of holidays or for some reason the buildings were closed for a few hours or for few days. So what we found was excluding these observations by considering them as outliers helped the model capture and use the most relevant information. On the feature engineering aspect, we used most of the raw variables, and our final models had a very simple basic set of features. Our best models did not have even more than 30 features. So our solution primarily focused on data cleaning and ensembling. So coming to the modeling piece, we built models at various different dimensions. So our first set of models were built at a site and meter level. So for every site and meter combination, we built models. Similarly, we built a model for every building and meter level, as well as we built models at every building type and meter level. So the models that were used were XGBoost, LightGBM, CatBoost, and for only the electricity meter, we also built feed forward a basic fully densed neural network. So there were some of these high scoring and uh, good solutions also posted on Kaggle publicly as kernels. So these, along with some of our models that we built on the entire data set, so that there could be some information captured from other sites which could be used across sites. And all these models together were used in our final ensemble. So the next step is the post-processing. So this ties in to the outlier removal and pre-processing that was done. Since we removed a lot of observations where the meter reading was 0, it artificially inflated the mean of the target variable of our training dataset. Now, since these outliers would be present in the test data itself, it became important for the model's predictions to be scaled back to the original scale. That is the reason we applied a post-processing factor of value less than 1 for each of our models. So the typical range of these values were between 0.75 to 0.98, and we found that using values between zero point 0.8 and zero point 0.9 gave our best results. So for ensembling and combining our models, we just used weighted average for every site and meter combination, we had a different set of weights. So the post processing factor, as well as finding out the optimal weights for every site meter level. So this was done looking at three base metrics. So one was our cross validation framework, which was done using the training data split on month. The second data point used was the public leaderboard score. And the third was we also validated the post processing and the weighted average on the leaked dataset of the leaked sites. So this combined and formed our final submission, which was used to submit on Kaggle, which ranked second place on the private leaderboard. So looking at the top features of our model, so if you look at this list, most of the features are the raw features. The building ID, hour of the day was extracted from timestamp, which is a very important predictor. Square feet is the area of the building. Month is the month in which the meter readings need to be predicted. The year when the building was built, the day of the month, and some variables on the air temperature. So most of the variables are either the raw variables or they have just been derived from time. So going over the code that has been shared, it should be fairly simple to run. It consists of Jupyter notebooks. The entire code base is in Python. So the first notebook is the LGBM notebook, which runs and builds the LightGBM models. Next is the XGB notebook, which builds the XGBoost models. The third is the CatBoost models. The fourth is the models that have been taken from the public kernels. The fifth and sixth are the notebooks that build the feed-forward neural networks. And finally, the seventh and the final notebook combines the outputs of all the notebooks and models together to create our final submission. So our final submission would be called final.csv, which was then used to submit on Kaggle. So overall, this code takes about 48 hours or maybe a little more to run. But in case this solution needs to be productionized, we highly recommend to use the first LGB notebook, because the light GBM models run fairly quickly. They would be able to complete in about 6 hours, and the performance of the light GBM models itself is very close to our final submission and scores really well on the private leaderboard. So the light GBM notebook is highly recommended since it's a simpler version of our entire solution, and it runs faster and it should be easier to productionize that. So this is our overall solution that we built for this competition. Feel free to reach out to any of us regarding any questions or any help that you would like. And thank you so much for hosting this competition on Kaggle. It was good fun participating in this and going through the data set. It also helped us understand energy consumption around the world. So thank you so much.